So another way to do this is with the Pythagorean theorem. And usually you've had that before now, but just in case, I'll just go over it again. We do it in chapter 9 actually, but it's kind of a thing that is always around. So Pythagorean theorem says a squared plus b squared equals c squared, where a and b are legs of a right triangle. The legs are the perpendicular sides. So in this case, we'd say that a is 6 and b is 8 and c is the hypotenuse. We don't know. So a squared and b squared, that's going to be 36 plus 64, which is 100. And then we're going to take the square root of both sides. Now technically that would be the absolute value of c, and we would get plus or minus 10, but we can't have negative 10 as the side of a triangle. That doesn't really make sense. So that just verifies that the answer is 10. Okay? Now, this is not highlighted but as a test question, but there's some stuff in here that would help us. So we have the coordinate plane, and we know that the blue triangle is congruent to the pink triangle, and they want us to find the coordinates of point B. Now, before we do that, we're going to do a little bit of a proof with the coordinate plane here. So if we know that these two triangles are congruent, then we know that AB is going to be congruent to BC. AB is right here. That is going to be congruent to this. So we could say that segment AB is congruent to segment ABCB. So we want to, now alphabetical is not the most important thing. Corresponding parts are. So kind of A goes with C here, A to B, C to B. And the reason we can say that, think about it, you're trying to practice your proof strategies here and work on memorizing some proof stuff. So usually after we say that two triangles are congruent, the next reason after that is CPCTC. Corresponding parts, these two segments correspond with each other, they're in the same place. Corresponding parts of congruent triangles are congruent. So that's how we got those. Now we could say that AB equals CB. Now with no mark over the top, that means it's a length, a distance. And so anytime, again, we've had this many times now, so if you're working on that in your head, hey, you recognize, I know what that means. That's the definition of congruent, because it's happened quite a few times. Now, if these two lengths are equal, that means something about B. That means that B is the midpoint of AC. And how do we know that? Because the definition of midpoint. The definition of midpoint is the point halfway in between where these two lengths are equal. Okay? So now, don't forget that definitions are biconditional, so if we say this, then that could be our next step, or vice versa. Okay? And same thing here with these. Okay? Definitions are biconditional. Either condition can come first. Okay, and now we're just going to use the midpoint. Now when you look at here, notice how I have the two highlighted. That's the scale. Now it's not a big deal on this one because they already have the points labeled for you, but I wish they didn't because I want you to think about that scale. Anyway, the midpoint is the average of the x's, so however you want to do that, 0 plus 10 divided by 2. And since I said 0 plus 10 divided by 2, the next one should be 10 plus 0, because we should go in the same order both times. So that's just going to be 5, 5. All right. So, until I recorded these notes on Spirit Week, Homecoming Spirit Week, this is my tacky tourist shirt. Also wear it on Hawaiian Day and stuff like that also. Okay, so when you turn this over and you go, oh my gosh, that looks intimidating. But let's try to tackle it one step at a time. Just like in life, you have a problem, you're going to try and just tackle that problem one step at a time. Okay? Okay, so one step at a time. So what's a step that we could take? The easiest step to take on this question is to remember, hopefully, from all the proofs we've done, that the last statement is what we're trying to prove. So segment OU bisects angle TOV. All right, so hopefully that was a free statement for everybody. Now, OU bisects TOV. Well, that would mean, to bisect, it would mean these two would have to be equal. So what I'm doing now is trying to come up with a plan. What's a plan? How could I do this? So I want that to bisect this angle. Well, what does that mean? It means I want these two angles to be equal. Well, those two angles are in two triangles, and those two triangles share a side. And if there was some way that I could prove that those two triangles were congruent to each other, then I could use CP/CTC to say those angles were congruent, and then I could use that definition of angle bisector to say this. So that's my plan. That's where I'm trying to get to. So if I want to prove these two triangles are congruent, that means I need to prove sides or angles are congruent. Well, I already have that highlighted in green for you. We've done that about 17 times so far this year. Maybe more if you count assignments. I don't know if it's 17 exactly. I made that up, but anyway. Okay, so we're going to say that segment OU is congruent to segment OU. I hope most of you, I hope all of you are filling in the reason for that. How do we know that? We said, highlighting green, two triangles that share a side. That's going to be the reflexive property of segment congruence. Okay, so we've got one side. We need two more sides. Well, this is on the coordinate plane. So usually if something's on the coordinate plane, one of the things we can do, we can either find slopes or we can find lengths, distances. So as I look at this picture, I see a couple easy lengths to get right off the bat here. This is 3. So TU equals 3. And VU is going to equal 3 also. Now, you might be thinking to yourself, well, we could have just counted that as well and got OU that way. We could have, but I think this is a good review of the reflexive property of segment congruence. So, all right, so we have those two lengths equal, so we probably should look at these two, OT and OV. So OT, let's see, OT, so that's going to be, if we use the distance formula on that, that's going to be negative 3 minus 0 squared plus 5 minus 0 squared. So that's going to be negative 3 squared, which is 9. That's going to be 5 squared, which is 25. So that's going to be root 34. Now on your assignment, some of you are putting decimals. We don't. I know the back of the book usually has decimals, and so you could do the decimal to check your answer in the back of the book, but we normally want stuff in simple radical form. So that doesn't reduce. Yes, it's 2 times 17, but those aren't perfect squares, so we're not going to do anything. We're just going to leave that root 34. Now, the other one is going to be 3 minus 0 and 5 minus 0. That's going to be the same. So OV is also root 34. Now, what did we just do? We used the distance formula. So just say the distance formula. That's our reason for getting those numbers. Now, look at what you have here. Okay? How do we come up with the next statement? Is there something, well, if that equals 3 and that equals 3, then they equal each other. So TU equals VU and OT equals OV. If A equals B and B equals C, then A equals C. That's the transitive property and they're all equal signs, so transitive property of equality. Okay. Okay, so now what? Well, we're trying to prove triangles are congruent. We want stuff to be congruent. So we're going to say that segment TU is congruent to segment VU. And segment OT is congruent to segment OV. Now, what happened from here to here? We switched from equals to congruence. We've had that several times. So we need to think that's the definition of congruent. So now we have this on this side and this on this side. So now we can say that we have triangle alphabetically OTU, OTU. Now when you go to list the second triangle, the alphabet doesn't have anything to do with it. You have to, so that's going to be triangle OTU, triangle OVU. And we have it marked on the picture. The reason that we can say that is side, side, side congruence. Okay? And what usually comes after side, side, side congruence? Or actually, what comes after two triangles being congruent? Now, the parts. So that's going to be angle TOU is going to be congruent to angle. Since we said TOU, we need to say VOU. And that's going to be corresponding parts of congruent triangles are congruent, CPCTC. And if we have these two angles congruent, how do we know that that bisects the bigger angle? That's the definition of angle bisector. All right? Okay. Now, that's not highlighted as a test question, but those steps and memorizing some of these things will help you for proofs of triangles. But there probably won't be one in a coordinate plane where we would ask you to do a two-column proof for a coordinate plane. That's why it's not highlighted. It's still valuable. It's still helpful. Now, we normally have something like this on here. Now, I'm going to say be careful. Okay, and you're all honors math students. Be careful. So, all of you should think about something right now. In life, if you were outside and you were walking and someone said, "Be careful!" Hopefully, you would want to know what they were talking about. Hopefully, you would look around. What's what? What's going on? Oh, there's a dog that's on the loose right there. Or that tree is about to fall. Don't walk under that. Or look out for that hole. Or there's an exposed wire. Don't electrocute yourself. Right? Like you would look. You would try to find, why am I being told to be careful? So on a test or in class, first of all in class, right now I'm telling you be careful. If you don't see what I'm saying be careful about, if you just go, oh, that's easy, and you wrote down the answer and you're sitting there and you're smiling, I've got the answer, and you can't look at that and say, oh, I see why he's saying be careful, then you need to think. And on a test, one way that teachers try to tell you to be careful is we put stuff in bold, or we underline things, we put stuff in italics. Those are some of the ways that we normally try to draw your attention to say, be careful on this question. So, the question maybe that some of you put, and this is what I'm talking about. If you just wrote down 6'4" and you had a big smile on your face, that's not good. Because when I said be careful, if the answer was 6'4", there would be nothing to be careful about. Think about it. Why am I going on about this? Because it's really a life lesson too. Like in life, be careful. Think about what's going on. But anyway, so the person who's all happy with their answer has not been careful. They didn't try to figure out, like, what is he talking about? So the problem here is, like I said on the earlier question, what is the scale? We don't know. There's no scale here. There are no numbers. So I don't know if that's going by 2s or 10s. No idea. That could be 60-40 for all we know. So we need to do this kind of a different way. We need to think about this. So this says H. This says this is H0. That means that to go over here, that's H. Well, everything on this vertical line has the same x-coordinate. So we should know that the x-coordinate of this is going to be H. Now if we come over here, we go across here, this is 0K. So this is K units up. We don't know what K is, but we know that this is it. So that means everything on this horizontal line also has a y-coordinate of K. So what we do know is that our answer should be HK. And now you say, okay, now I see why you said be careful. Okay. So from now on, when you're told to be careful, look for that. Okay, one more of these and we'll wrap this up. We'll be done for this lesson. Again, I just highlighted that number 7 in pink there to emphasize. So everyone in this class should be doing something right now. And there's no, oh, I'm not going to prove. So that everybody should get 1 point right here, at least. There's a free point. It's just memorization. It's like you don't have, there's nothing to understand. It's about memorizing. It's like if I say that that this is pink, you say I don't understand. There's nothing to understand. You were told this is pink. You know it's pink. Okay? Now there's stuff that's tricky in here. I'm not saying that, but I'm saying you've been told that when you're told to prove something, that is your last statement. So knowing to write this right here is the same as knowing that this is pink. That doesn't really take you. It's not like you have to figure something out. The other steps, a little bit harder. But this, there's no excuse, no good excuse. I'm sure there are excuses, but no good excuse for not being able to fill this in right here. Okay, bam. You just got 1 out of 10 points. It's better than 0. Okay, so now we have to start somewhere. So we want to prove that these two triangles, OPQ and QRO, we want to prove these two triangles are congruent. So that means probably sides. If we're on the coordinate plane, we're probably not trying to figure out angles. We're probably trying to figure out sides. So I already have one highlighted in green. So again, I don't understand. There's nothing to understand about that green highlight right there. That's memorize. That's recognition. Green. That's green. How do you know that's green? Because somebody told you that when you were a little kid, you wanted to know everything. And your parents or somebody told you, hey, that's green, that's blue. And you were like, green, blue. And you were happy because you were learning stuff. And your brain was getting bigger and you were figuring the world out. Okay? So, segment OQ is congruent to segment OQ by reflexive property of segment congruence. Okay, so we have that. Now, we're on the coordinate plane. We're trying to prove these two triangles are congruent. There's 4 main ways to do that. We could think about that right now. What are they? They're side, side, side congruence, side, angle, side, angle, side, angle, and angle, angle, side. And what lesson is this? 4.7. So we probably have had hypotenuse leg also. So actually there's 5. There are 5. But again, there's no right angles there. Not really going to do much angles. So we're probably using side, side, side. So we need to find the length of some sides. So OP. So let's look at the OP. So, well, don't say 4. Be careful. It's not 4, it's n. It might be 4 if n is 4, but the distance from here to here, so we're trying to find a distance on a vertical or a horizontal, we can just take the 2 coordinates and subtract them. So n minus 0 is n. So that length is n. All right, and if we look over here, that's going to be k plus n minus, this is k right here, minus k. So that's just going to be n. So RQ is also n. All right. Now, it's a little bit trickier, I suppose, but let's do this one first. So OR. So the distance from O to R is going to be h minus 0 squared plus k minus 0 squared. So that's going to be the square root of h squared plus k squared. Okay? So that was OR. H squared plus k squared. Now, up here, what did we do here? OR, so PQ. So PQ is going to be h, again, it's h minus 0. So that's going to be h squared. And here, what is this? K plus n minus n. So it's going to be k plus n minus n. The y-coordinate here minus the y-coordinate there. So those n's are going to cancel out. And so PQ is also h squared plus k squared. Okay, and all of that is the, again, same reason as above, the distance formula. Okay, and then again we just go back to kind of memorization and having done stuff over and over again. So here I have this equals n and this equals n, so that means they equal each other. So OP equals RQ, and then down here OR equals PQ. So that's the transitive property of equality. And now we're going to switch those to segments. And maybe I should have waited a second there to give you a chance to think about that. You could always be pausing anytime. Anytime you're doing a proof, if you could pause between each line to make sure you're trying to get those yourself as much as possible. And then down here, segment OP is congruent to segment, wait a second, OR. I already have OP, RQ, OR, PQ. Okay, and if you don't know the reason for that, you're not really paying attention very well right now. So the reason for that is the definition of congruent. And I could have marked those sides on there. I guess I should have done that here. So that's going to be this side and this side. And this is going to be this side and this side. Okay? And so that is going to be side, side, side congruence. Okay, so it's about that time. Have a good day, and good luck with that assignment.